Good morning, everyone, and welcome. Thank you all for joining us today. I'm Revati Kumar, your host for this session. Before we start, a quick note. If you have any questions during the session, please write in the chat. Our experts will answer you via email. So, AI assisted development is evolving rapidly. Today, generating code is easier than ever. But moving from a working prototype to a production ready application is where the real challenge begins. Questions around scalability, maintainability, governance, testing, and engineering workflows are becoming increasingly important as teams adopt AI assisted development in real world environments. That's exactly what we'll explore today. In this session, we'll discuss how organizations and engineering teams are using Claude Code beyond rapid experimentation to build scalable, maintainable, and production-ready applications. We'll also look into practical approaches to improving developer productivity, streamlining engineering workflows, and preparing AI-assisted projects for real-world deployment. Now, it's my pleasure to introduce today's speaker, Murali Kaniyappan, has been working closely with teams building AI assisted applications and modern engineering workflows focusing on scalability, governance, and production readiness. We're excited to hear his insights today. Welcome to the session, Murli. Over to you.
Yeah, thanks, Revati. Yeah, good morning, good evening, all from whichever part of the world you are. Today's session is going to be, two parts. So one is the first part is we are going to see the theoretical one. The second part is we are going to see how the prompt will be and what are the right prompts that we need to give to generate production ready application code. Okay. So we have come up with a 10-step workflow for shipping production ready software using AI Opus in Cloud Code Opus 4.7. It is well architected, properly validated, secure, and maintainable. So there are two approaches. Neither of them is great. One is using without AI, meaning before AI came into the existence, so we were using or we were spending a lot of time or weeks on uh, coming up with an architecture decision and spending months writing boilerplate codes. It is slow but deliberate. So there is no clear separation of concern and intentional design choices baked it from the start. With AI, it shortcut every architecture decision, vibe code 98% of the project, we can ship it quickly, but with dangerously low quality that accumulates as production debt. The real problem is if you don't deeply understand your language, framework, HTTP, database, and architecture patterns, you cannot tell when AI generated code is subtly wrong, and it will be often enough to matter in production. AI amplifies what you already know, but developers with deep knowledge who operate AI skillfully will be the most valued engineers going forward. Why most AI generated code fails in production? See, in vibe code, you simply say, hey, write me an API with CRUD operations, and then as soon as it generates and compiles, with as a developer, we tend to copy that and embed into the application. But it consistently lacks the quality that matters in production systems. So we have broadly categorized into four categories. One is no architecture, meaning there is no consistent structure, no separation of concern, no module boundaries. The code base becomes a tangle and hard to navigate and impossible to extend. And there is no resilience. There is no error handling mechanism in place, no structured logging, no observability. When something breaks in production, you have no signals to diagnose it. And no safety, poor input validation, hard-coded configuration, no security considerations, vulnerabilities that a structured review would catch or silently embed in the code. And no test. So there is no test suite, no maintainability, no confidence in production. Changes become risky guesses rather than deliberate and verified updates. The root cause is A has no context about your project, no architecture decisions, no team conventions, no deployment constraints. Give AI structured requirements with the code examples and the output quality increases dramatically. That's what we are going to see in the upcoming slides. We have come up with 10-step workflows and split into 5 phases. First phase is requirements planning, and then second one is architecture and specification. Third one is backend implementation. Fourth is coding the front end, and finally the deployment model. And in each phases we have 2 steps. The first one, in requirements planning we have business requirement, both functional and non-functional. Under the architecture you have got business architecture and then backend specification. In the third one, backend implementation, you have got code the backend and review and refine. And the fourth one is front end specification, code the front end code. And then the final one is automation of CAD. Along with the automation of CAD, you are going to involve human loop for reviewing and deployment. Phase 1 and step 1, business requirements. Okay, every project starts with a business requirements document, BRD. Okay, you have to upload into a cloud code using Opus 4.7 in plan mode. This forces cloud code to analyze before generating anything. The goal is to eliminate every ambiguity before touching architecture. For every unclear requirement with, you have to have some flag saying that clarification needed, so that when it generates it is flagged with the clarification needed, so every ambiguity becomes a bug or a recycle later, which will be resolved at the first stage itself. And the stage, I mean step 2 in the phase 1, it's very important. Most of the developers skip this phase. I mean, this skip this step, non-functional requirement. This is, I mean, client is not going to share non-functional requirement, whereas as an architect, you have to consider all of this aspect, like availability. So what is the uptime SLA, acceptable downtime per month, and what is the performance, whether it is a P50, P95, P99 API response times, and page load targets. The third one is scalability. How many concurrent users are going to use your application? What is the peak load scenarios? And what is the data growth rate? And security. What is the authentication model you are going to implement? And what is the encryption algorithm that you are going to use? What is the compliance requirements like EPA, GDPR, etc., SOX, and etc. And maintainability and testability. So it's a coverage targets, CA requirements. See, I have mentioned only a few of the NFR non-functional requirements. There are plenty, and it varies from application to applications. These constraints directly drive architecture decision, which will be covered in phase 2. Phase 2, architecture and specifications. In the step 3, you have to design the architecture. Use Claude as an architecture consultant, not an authority. You have to ask many options, at least minimum 2 to 3 options with the pros and cons with NFR trade-offs. Then finally you have to make the decision yourself. See, you should not accept the first suggestion. You have to go through two or three suggestions and make your decision out of those. So for most projects, a modular monolith with vertical slice architectures gives clean module boundaries without microservices complexity. Later, if you want to convert into microservices, it is very easy. See, you have to challenge every proposal. Why this over X, and what happens when Y fails? The output of this step is signed off architecture document describing system architecture, technology choices, and reasoning behind each decision. In the step 4, generate the backend specifications. A backend specification is a detailed MD file. MD file is nothing but a markdown file, so it has a complete information that a developer could implement the entire backend without asking many questions. Before generating any specification or code, set up a clean Claude.md file, the single most impactful file that you can do, and it tells Claude your tech stack, architecture, conventions, and patterns. So every generated file is consistent from the beginning. Keep your Claude.md file under 100 lines, and if it is more than 100 lines, split into multiple files and refer those files using at import syntax. In the phase 3 backend implementation, you know, with the cloud.md and the specification in place, the implementation prompt is just 3 sentences plus file references to an existing code samples. Claude combines context from all the sources, Claude.md for patterns, and the specification for business rules, and references for concrete style examples. The most powerful technique, instead of describing patterns in words, point to the actual code. Once the code is generated, you have to point to the particular code so that it identifies what type of code is generated and what patterns it followed. And based on that, the further code is generated, and your pattern, your architecture, everything will be intact. In the sixth step, you have to review and refine. Open a new session of the Claude code and uh, use a three phases approach. One is the code quality. You have to have proper naming conventions. You have to have dry principle. You have to have dead code consistent handler patterns. And then in the performance, you have to have unnecessary DB round trips, asynchronous or await, cancellation of tokens, refresh of tokens, and finally security. So authentication and authorization, input validation, the SQL injection, sensitive data in logs. Never fully trust AI generated code. Humans catch business logic errors that pattern matching AI will miss. Okay. The most powerful technique is, instead of describing patterns in words, point to the actual code files as I said earlier. So Claude reads them and follow the same pattern and style towards the entire application. Yeah, the phase 4, step 7, front end implementation. So create a product document requirement. It's called a PDR, referencing your backend API. It must include authentication flow, per page API calls with exact JSON examples, UI layout, validation rules, matching backend validators, conditional rendering based on links and user claims, and paging behavior. The PDR should be so complete that a front-end developer or a CLAD can implement the UI with zero guessing. And in the step 8, code the front end. create a separate Claude.md for your front end covering your stack, which is similar to your backend specification. And in this front end specification, you have to specify what is your backend tech stack like React 19, TypeScript, Tailwind, CSS, Just and etc. and followed by conventions. The implementation prompt is intentionally short. Claude.md handles conventions. The PDR handles pages and API contracts. The prompt only needs to specify visual design preferences, accent color, responsive breakpoints, loading states, and inline error messages behavior. In the phase 5, we are going to discuss about deployment and final review. So after creating your BRD and backend specification, front end specification, and then front end architecture, you have to have an approach for automation deployment. Generate a GitHub Actions pipeline that triggers on push to main and on PRs. PRs is nothing but pull requests. The pipeline should run backend build and test, build and push a Docker image to a private registry, and run the front end linter, test, and production build. With backend and front end jobs running in parallel to minimize the total pipeline time. And you have to have caching mechanism, cache NuGet package and npm modules for faster builds. Never hard code any secrets like your connection strings or any of your the Azure API connection strings and with the other relevant keys. Use environment variables exclusively so that in the during runtime it overrides dynamically. In the step 10, okay, so after once the automation deployment is configured, and you have to, I mean, the human in the loop should be, reviewing your deployment plan and all other steps. The final step is entirely human. The run the application end to end, test every user flow manually, verify error messages, authorization for all user roles, and critical edge cases. What happens with an empty form submission, and what happens with concurrent edits to the same record, what happens when the database is down. So read through all the handlers, validators, and endpoints yourself. AI follows patterns. It does not understand your business domain, but we do. The key takeaways is, so far we have covered only the theoretical part. The key takeaways are fundamental still matters. AI amplifies what you know. Deep expertise in architecture, databases, and security is what separates. Context is everything. So you have to set the context in Claude.md with the detailed specification of your backend and front end. And you are the architect. Please remember you are the architect and AI is an consultant. It's not an authority. Next, we are going to see what are the right prompts that we can give to generate the quality, production ready quality software. One second. Yeah, yeah. The first prompt, as we discussed earlier, this is a key prompt. Define business requirement. In this uh, in this step one, you are a senior business analyst reviewing your business requirements document. Read the attached BRD and analyze it thoroughly. For each failure, identify and document all user roles and their permissions, core entities and their relationships, complete user workflows step by step, business rules with validation and constraints, edge cases and error scenarios, and any ambiguities or missing requirements. Present your analysis as a structured document. Flag every ambiguity with clarification needed. As I said, I mean in the I mean, a while ago, if anything is unclear, then clarification needed. It should be flagged with clarification needed tag so that we can resolve then and there. The goal of this step is to eliminate ambiguity. Every unclear requirement will become a bug or a rework cycle later. Use Opus 4.7 in plan mode to force analysis before generation. Why I'm suggesting to use Opus 4.7 is it is somewhat matured when compared to other AI tools. Yeah, define the non-functional requirements. Yeah, define non-functional requirements. As I said, the client may or may not give this information. It is our architect in duty or responsibility to define availability, performance, scalability, security, and cost. So when it comes to availability, what is the uptime SLA? Whether it is 99.9% uptime, or what is the downtime during deployment, and what is the performance API response time, whether the response or the latency we need to define. It has to assume that it has to load or provide response within 1 or 2 seconds. And the scalability, if number of users exceeds, I mean during a seasonal time, your system should support without any backlog. And also the security, whether RBAC is implemented or ABAC is implemented, and then encryption is implemented. And finally, what is the cost? I mean, what is your infrastructure budget, ceiling, and then cloud provider preferences, and self-hosting versus managed services trade-offs. And design the architecture. Okay, for acting as, I mean, this is a prompt. You are acting as a solution architect. Propose 2 to 3 architecture options grounded in the business and non-functional requirements. Evaluate each on its merits before committing to one. For each option, document architecture style, modular, monolithic, microservices or serverless architecture, module-wise or service-wise, boundaries, database choice, API design, RESTful, whether it is a RESTful or GraphQL or gRPC, authentication and authorization strategy, deployment model, and infrastructure topology, and finally the evaluation criteria. There are pros and cons related to the project constraints. With NFR, each option satisfies or it trades off. What is the team size and required expectation level, estimated implementation complexity. The output of this step is living architecture document covering system architecture, technology choices, and the reasoning behind every decision. Yeah. Backend specification. The backend specification, when you are setting up a cloud.md file, what to include and what not to include. So you have to be more specific. So for example, in the document, in the markdown file, you have to include tech stack with a specific version, architecture style, and project structure, file naming conventions, patterns that you use and patterns you explicitly forbid, and common commands, testing frameworks and naming conventions, domain terminology, and then when it comes to what not to include, your secrets, API keys, or connection strings, code formatters rules, use editor, sorry about it, use dot editor config for that. Obvious framework knowledge Cloud already knows, large code samples, reference files instead of using large single file. Yeah. Your project structure, step 4 continued, your project structure and file naming conventions. You have to have module structures. You have to have source module dot name. For example, what is the name of the file that you are referring about, that is that is specifying about your domain, core, infrastructure, public API. What are the public APIs exposed to the public, and what are the common APIs, and what are the private APIs, and what are the host, and what is the these are the structure, module structure, and what are the patterns that we need to use: high handler, high API endpoint, route constants, and bogus testing for bogus test for data seeding, and then future file naming. You have to have proper use cases, use case names dot endpoint dot handler dot validator. These are the prompts that we generally use or will feed into the cloud opus 4.7. And what patterns we are not supposed to use: people generally use both entity framework and repository pattern. Actually, if you use entity framework, you are not supposed to use repository pattern, because it is in entity framework, it internally handles repository pattern. So if you use both, then it is redundant. So likewise, you are not supposed to use certain things: auto mapper, mediate, or exceptions for business logic flow, etc. And code the backend with the Claude.md and the specification in place. The implementation is the implementation prompt is intentionally very short, because Claude has already everything that we have fed. So you are a principal developer producing code of exceptional quality, following clean code principles. Read the backend specification and implement all the features. You have to refer the .cs files if it is a C sharp, or any other files if the language is different from .NET. When it comes to specification, you have to provide entities, endpoints, business rules, and validation logics. The source of truth for what to build. And you have to refer files. If it is more than one file, then you have to have at symbol with the references of that particular files. And the next step is review and refine. And there are three passcodes review. One is code quality, whether it is consistent, and consistent naming conventions followed across all the files, and all handlers following the same pattern, and there are no unused imports or dead code, and it is followed with the dry principle. And in phase 2, in pass 2, performance, unnecessary database round trips, all asynchronous methods properly awaited, cancellation tokens mechanism in place, and refresh token also uh, to be in place. And finally, the security: on all endpoints properly authorized, all inputs validated before processing, and you have to ensure that there is no SQL injection, and there is no sensitive fields excluded from responses and logs. And like like your backend specification, you also have to have front-end specification. This front-end specification.md file will have all of your front-end needs. For example, conditional rendering rules, user policy constants, and then and what is the pagination contract? So how many records should be fetched at a time? And in case if there are 1,000 records, and how many you have to fetch at a given time? And then what is the response shape, whether it is a part of item collection, total count, total pages, and also UI controls, then page number selector, previous and next buttons, and pagination option in the drop down. Every paginated endpoint in the backend must return the same envelope shape. Define this contract in the architecture document and enforces it via an architecture test. Moving on to front-end specification, paging, and API contracts. Once the paging, once the front-end specification is ready, then we are almost done with the applications. Next is clean and professional design. Use your accent color consistently, rounded borders on all interactive elements, maintain visual hierarchy across views. I mean, whatever I'm saying, these are the prompts that you need to feed into Opus 4.7. These are not, these are the, I mean, these are not sentences that I'm saying. These are the real prompts that we have used and validated. And what is your responsive layout? So about a desktop, tablet, and mobile breakpoints, and there should not be any horizontal or vertical scroll. So that it should be touch friendly and tap targets on mobile, and then loading and error states, loading skeletons or spinners for every API call, and then inline error messages displayed near the relevant field, never generic toes only. Okay, yeah, the, the last but one, the ninth one step is, as we discussed, you have to do the automation of deployment. You have to give prompt in such a way that it generate uh, code for the automation deployment also. It can generate a YAML file, and later you can configure for your respective environments. Generate a GitHub Actions pipeline that covers both the backend and the frontend in parallel jobs. Speed matters. Use caching mechanism aggressively. Secrets must never be hard coded. Okay. As soon as the file is pushed to main and pull request is raised, it should be triggered, and it should run certain task: restore, build, test, Docker build, and push to the GHCR. In the front end, installed deps, lint, test, and build. Finally, you deploy to the targeted environment. Okay, the steps are: first, push the main and pull all the requests, and parallelism, backend, frontend run as a separate concurrent jobs. And third one is caching, NuGet packages and npm modules cached between runs. And finally, the secrets, all credentials via GitHub environments, secrets should be in secrets and should not be exposed in plain text. And finally, human in the loop, human intervention. Okay, so assume that your code is ready with all the necessary things. Even then, AI generated with a powerful code, but it is up to, I mean, it is up to us to ensure that the code quality is good, and that is why we have to test the application thoroughly. The final step is entirely human. AI is excellent at following patterns, but it does not understand your business domain as well as you do. So no pipeline replaces a through thorough human walkthrough before shipping. So what we are supposed to do: run the application end to end and review the generated code yourself once and test all the test cases. And finally, you can be sure of production ready code. Thank you so much. That's it. If you have any questions, please feel free to post it to our uh, mail info@exocorp.com. We are happy to assist you, and we will be able to share the right prompts for your scenarios. Thank you so much for for your time. Over to you, Revati.
Thank you. Thank you, Murli. That was an interesting and wonderful session. Thank you, everyone, for being part of the session. For queries, please write to info@hexacorp.com. Please follow our LinkedIn page, and the link is mentioned in the chat. To explore our services, please visit www.hexacorp.com. Have a great day ahead. Stay tuned for the next.